Hello and welcome everyone. So I'll be explaining the recent Codeforces round 767 Division 2 problem B named GCD Arrays. Okay, first, before jumping on to the solution, I'm going to make some claim and fact that's going to help us in order to solve this particular problem. First of all, the first claim is that any two numbers, if their difference is 1, like if they're arithmetic progression or any series having an arithmetic progression and their difference between two consecutive values is 1, or like for example, let's take two numbers and their difference is 1, then the GCD would also be 1 always. So in terms of arrays, let's say I have 5, 6, 7, 8. As you can see, it's an arithmetic progression with a difference of consecutive two numbers equal to 1, meaning and if I make a GCD of all of these numbers, if you don't know how to make a GCD of an whole array, it would be something like this. You're gonna make GCD of 5 with 6, and then the value of that GCD, let's say x, you're gonna GCD x with 7, let's say it comes y, you're gonna GCD of y and 8, so on and so forth until you get the last GCD, and that would be the GCD of the whole array, and you'll see that it will always be 1. Okay, and the question is, why is that 1? Because it's any two numbers, like consecutive two numbers difference is 1, and I mean, if you could analyze every example, you will see that the GCD would always result in 1 because the difference is 1. It can't get any further than that. So that's an obvious reason why it's going to be 1. So yeah, that was the two facts that we need to know. Now if I jump onto the problem, what does it say? It says that I'm going to be given two ranges L and R, and the array would consist values from L till R by increasing only 1, meaning that it's the exact array that I was talking about earlier, where the array would seem something like this. If L was, let's say L was 2 and R was like 10, the array would be 2, 3, 4, 5, so on and so forth, and finally 10. So it's going to be an arithmetic progression with consecutive elements difference equal to 1. Now, okay, yeah, that's exactly what we have to do. And okay, and we're also given another integer k, and okay, we can do some operations to that array, and at most k times, and okay, and what are the operations? And the operations are something like, okay, the operations are, you will choose two integers, and you will have the authority to remove them. They're one occurrence. There could be multiple of those elements, because when you remove their occurrence, one occurrence of these values, let's say 2 and 3, I want to remove 2 and 3. If I want to remove, let me tell you one thing, it's the operations, all of these operations will belong to only one, I mean only for one operations, for one times of operations, these three tasks are gonna be accomplished. Okay, so like, you're going to choose two numbers for each operation. You're going to choose two numbers. You're going to remove their occurrence of one. As you can see here, 2 and 3 are only occurring once, so they're going to be removed. And you're going to insert something to the array, and that is going to be the product of these two elements, which is 2 and 3. I'm going to 2 times 3, which is 6. So the new array would something look like 6, 4, 5, 6, 7, 8, 9, and 10. Okay. Okay, now what we have to do, okay, so I guess you've understood what I just told you, and yeah, that's exactly the operations are. They do mean that. Now, finally, what you have to do, you have to tell whether it's possible to have the GCD of that array transformed after some operations of k, obviously. Whether the GCD of that particular array is greater than 1 or not. If you could make somehow, or if it is possible to make the GCD of the corresponding array greater than 1, then the answer would be yes. Otherwise, if you could not transform that, the answer would be no. Now, the most easiest way to think about this problem is, as I've already told, those facts, that consecutive numbers with difference 1, their GCD will always be 1, which means, and also one thing, if the numbers were something like that, let's say the numbers are only even, any even number, if you it doesn't matter how many even numbers are there, their GCD will always be equal to 2, because every even number has a multiple of 2, right? They're all divisible by 2, so their GCD would obviously be 2. So what is the problem then? The problem is with the odd numbers, because odd numbers can both consist of prime numbers, because most of the prime numbers do consist, and they are mostly odd numbers. So we need to deal with them too. The most easiest way to deal with those numbers is that, let's say 2, 3, 4, 5, 6, and 7. I'm going to make a claim. Okay, first of all, in this array, how many even numbers are there? I mean, my goal would be to somehow erase these odd numbers. Now, the best way to erase these odd numbers, why am I erasing the odd numbers? Because they are a burden to my to this array, because they could build a GCD of 1 inside this array. So it's gonna be a greedy choice to erase every odd numbers as you can as possible. Okay, so that will be my goal. I'm gonna erase the odd numbers. The best way to do that is to erase it with an even number. Why is that? Because even times odd would always give me an even number. So it's obvious that I'm gonna choose a pair of, for each operation of k, I'm gonna choose a pair of an even number and an odd number, such that I could remove them, and the value that's going to be inserted instead of these two is going to be an even number, because I want as much even number as possible, such that the GCD of the whole array does not become 1. So that's exactly what I'm going to be doing. Exactly, that's exactly what we have to do. And we're gonna, as you can see, for this particular example, I have to make at least 3 operations to make this successful, because there are 3 odd numbers in here, right? Please take a look at it. Like, how is that even going to be possible? Let me tell you. First operation would be 3 times 2, 6, 4 times 5, 20, and then 6 times 7, 42. Now if you do an operation of GCD, it's going to become 2, which is greater than 1, right? So that's exactly what my goal is. My goal is to track how many odd numbers are there inside an LNR, and also I'm gonna have to check whether that odd number is less than or equal to the number of operations that I can make. If I could do that, then there is a possibility that I can make the array or like I could make the array feasible, or the solution that the author wants from me, or it's gonna be yes, or otherwise the GCD would be 1. Okay, so that's exactly what we're gonna have to do. Let me jump into the coding section to elaborate the process more. This is the coding part. First we took the test case, then we took L and R. Okay, there's an edge case here too, which is what if the L and R are same? If the L and R are same, then you could say that there will always be 1 numbers. You cannot make any operations, because in order to make operations you need 2 numbers, right? So you can't just make a claim that. So if L and R are same, meaning if the resulting array's length is 1, just check whether the value here is 1 or not. If it is already 1, the answer is no, because you cannot make any operations such that and thus it will result as the GCD of the whole array would be equal to 1. Otherwise it's going to be equal to, so then the answer would be no. Otherwise the answer would be yes, because it's not 1, so the GCD would not be 1. That was the slight test edge case here. And apart from that, here what I did was trying to find out how many even and odd numbers are within a range. That's exactly what I did. You could easily do that if you know how to find out from a prefix of array, how to find out the value of a subarray from using prefix technique. If you know that, you will definitely gonna be able to find out how to find out number of even and number of odd numbers inside a subarray of L till R, which is in this case an array. Okay, from L to R. Yeah, so that's exactly what I did here. And finally, the final case is that if my K, meaning the number of operations that I can make, it's greater than or equal to the number of odd count. If that is true, then yes. Otherwise, the answer is no. I hope you liked the solutions and understood the problem. And yeah, I'm gonna wrap up this video right now. But before that, I want to make an announcement, and that would be I've actually created a playlist inside the inside the description box. You will see I've created a playlist naming a corner case, where I will discuss several corner cases regarding different aspects of competitive programming concepts, such as trees and graphs. I hope you would look into that. Yeah, so till next time, goodbye.